Hi guys, this is Miss Hart-Townsley, and I just wanted to walk you through the periodic table. I have made a copy for each one of you. When you're in to visit the e-cafe, I can hand you this, but this tutorial is going to show you how to mark it up. So the first thing I wanted to talk about is our how to read the periodic table, and so I've got some writing tools over here. What I'm going to do is for each of these parts of the atomic of this square, I'm going to show you what they represent. So for example, on I've just got hydrogen pulled up here. This number 1 right here is going to stand for, and I'm just going to draw an arrow. If you want to draw an arrow, or if you want to maybe redraw these squares down here at the bottom, so you could essentially just make a new square down here. Remember, you can use these periodic tables on your exam, and so it might be well worth it to have this as a key, or I guess you could call it kind of a cheat sheet. Okay, so when we have hydrogen, it is element number 1, and that 1 is the number of protons that hydrogen has. All right, so I would like you to label number of protons. Okay. I also want you to know that the number of protons is the identity of the atom. Okay? What this basically means is that we cannot change the number of protons without changing what type of atom we are dealing with. Okay? You can tell Miss Hart writes real well with her mouse there. Okay, so this number 1 is the number of protons in the atom, and it's also the identity of the atom. Okay? Right here, let's go ahead and get a different color here. I'm going to circle the letter H, and this is just called the atomic symbol. Okay, so I'm just going to write out here symbol. You do not need to memorize these, but it would probably benefit you to become familiar with them. Okay, so at least go through and know the big ones, know the ones that are found in living organisms, kind of know how to describe that these middle ones here are metals. Okay, these are going to be your alkali metals, earth metals, so on and so forth. So it'd be good to get familiar with some of them, but you do not have to have them memorized. Okay, I'm going to go to another color here. Right over under here is going to be what we call the atomic mass. Okay, so I'm going to bring that out here a little bit, and I'm going to put right as neatly as I can. Atomic mass, like I said, you could be doing this. Oh, that yellow is hard to see there. Okay, actually, so let me erase that real quick. I'm going to go back and I'm going to make sure we can see this real well. So let's change colors. Let's do this dark purple. Real quick, dark purple. Okay, so once again, this is going to be called the atomic mass. Okay, where I was going with that earlier is that you can make yourself a little key down at the bottom of your periodic table. I did leave room just for that instance. So here we go, atomic mass. Okay, and so we also need to know the atomic mass is equivalent to protons plus neutrons, because those are the only two elements that are parts of the atom that have a weight. So I know that anything, the atomic mass is going to be the addition of protons plus neutrons. Okay, so up here I have 1 proton, and my mass is 1.008. So if I round that to the nearest whole number, I get 1. That means that this hydrogen atom only contains a proton. It has no neutrons. Okay, the other thing that's very helpful about this table, I'm going to change, I've used red, blue, purple, let's go with maybe a bright pink here, is right over here. This number is going to be equivalent to the number of electrons. Okay, in neutral atoms, the number of electrons always equal the number of protons. Sorry, there we go, electrons. Okay, very good. So they're always going to be equal to the number of protons, or if you have a periodic table like the one I've given you, you're actually going to be able to count. So for example, in beryllium, 2 plus 2 is 4. We could go over here to nitrogen. 2 plus 5 is 7. Okay, but notice those numbers, those quantities, if you add them up, they're always going to be equal to the number of protons. Okay? All right, so now that we know how to read the periodic table, let's do a little bit more with our electron configurations. And so what I'm going to do is I'm going to go over here, I'm going to grab a shape, okay, and what we're going to do is we're going to look at the 4 different orbitals, and let me make sure I'm in a clear box here, and I've got, okay, so it looks like we're in red, the first 2 columns. All right, so I'm going to go ahead and keep that red color. So I'm going to choose red. The first 2 columns are going to be the s orbitals. So let me grab a hold of this real quick. I want you to make sure that yours is perfectly straight. I want to get this right there. So in 1 and 2, we're going to have what's called the s orbitals, and I labeled it down here with the red s. Okay, so let's grab a shape again. We'll do the square. Let's go to that. Maybe that bright yellow will help us out in this. So bright yellow, and let's go over here. We've got our, I'm not sure why that's not, we'll have to straighten this up here in a second. Okay, right here, we've got what we call the d orbitals. Okay, so I'm going to write the letter D right here, and I'll just no, I won't. I have to get a pen first. Okay, I'm going to write the letter D in bright yellow right here, so we remember that that's a D orbital. Okay, and just bear with me while I erase my mistake right here. Please and thank you. Okay. I'm going to go back to shapes again because we still have a couple orbitals to do. Let's change this to let's just go black so that we can make sure we see these. Our next one are going to be the p orbital, which is going to extend all the way through. What we would call the transition metals, the halogens, the gases, okay, all of these elements over here. And so in black writing, I'm going to write P. Let's put it right here so we can see it. Okay, and if I were you, I would make a straight line, see how we can go right around the boxes. So use a ruler and make a straight line right around all of these. Okay, I know mine are kind of circular here. Be sure to not include do not include helium. In that, helium actually can go right over here with the s's, and so this is one noble gas that only has an s orbital. Okay, just FYI, and I'll use a bright pink shape, so I'm going to go to shapes. I'm going to choose those, and I'm going to put this bright pink down here, and that is for our lanthanides and actinides. We're going to remember that those are bright pink. This is in when we deal with f orbitals. Those are the elements that have f orbitals. Okay, so a couple of things that let's review real quick. We can label on our periodic table. We can label how to read the individual boxes. We can label protons, the atomic mass, which tells us protons plus neutrons. We can also label the electrons and how many there are. We also need to be familiar with the symbols. Secondly, we can label on the periodic table the different electron configurations. So these, let me make sure I get an arrow here. Oh, it's not letting me. There we go. All right, so make sure these first 2 columns, these are going to be what we call the s orbitals. Okay, they have s-shaped orbitals. These have the d-shaped orbitals, p-shaped orbitals, and f-shaped orbitals. Okay, the last thing, or one of the last things I want to show you, and I'm just going to stay in black. I'm going to get my pen function in black. I want to point out right here that we have pen. Oh, and I've chosen black. I think I've chosen black. Okay, I want to make an arrow. Miss Hart is having some technical difficulties right now. Let me pause the video I can. All right, sorry about that interruption. I got my pen to work. One of the last things I want to show you is that when we look at the different rows of the periodic table, this is going to identify how many energy levels the atoms within this row have. Okay, and so for example, if I wanted to apply this, we can just pick any element. I'm going to go through and let's do beryllium. Okay, and so for example, I'm going to do beryllium, and I see that beryllium is in the second energy level, okay, but it also is in the s orbitals. It doesn't go outside of the s, and so with these 4 electrons, I have 2 in the first s orbital and then 2 in the second s orbital. All right, I guess that's something else that we could write. So when we have these orbitals, I know that there are 2 total. Okay, this is 1 and this is 2. In the d orbitals, so I'm going to go change to that d, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, so I'm going to just put it right here and just put d equals 10. So how many electrons can I fit in the d orbital? Is 10. Okay, I'll change to my black marker. P orbitals, I've got 1, 2, 3, 4, 5, 6. And so P, I can fit 6 electrons. Okay, and then if we were to go to F, and we'll go across 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. I should have gotten 14 there. Okay, and boom. Nice form, Miss Hart. Okay, so so let's go back to our beryllium example. We know that beryllium has 4 electrons. We know that it only has S-shaped orbitals, so I must have 2 in the first and 2 in the second. Let's go ahead and choose a different one to kind of make this make a little bit more sense. So let's go over here to phosphorus. Okay, phosphorus is going to have 3 energy levels. I know that 2 of them are going to be S's, and I know that I am in the 3, so I'm on the 3 P, because I'm in the P block, electron configuration. All right, so for phosphorus, if I were to just go through, I could go through each one of these. So I've got 1s1, 1s2, 2s1, 2s2, all the way down, but I could also kind of do a shortcut. I know that it has 2 S's filled up before it goes to P. So I'm going to go ahead and start writing the notation. So I've got 1 S2, right? Both electrons. 2s2 fills up the second S energy level. Okay, so 1s2, 2s2. The next one over, I go all the way to P, and it's in the 2p, and all 6 electrons, all 6 p orbitals are filled. So p1, 2p1, 2p2, 2p3, 2p4, 2p5, 2p6. Then I go down to 3s. So I've got to put 2 electrons in the s orbitals, so 3s2. And then I skip over all the way to 3p. So I have 3p1, 3p2, 3p3. Okay, so my orbital notation is 1s2, 2s2, 2p6, 3s2, 3p3. All right, guys, I hope that was helpful. If you wanted to give yourself those examples as well on your periodic table, I think that'd be beneficial. Just remember that we got to count over on these are the energy levels, and you have to fill all lower energy levels before you get to the next. Okay, remember we don't get to D's until here. We have P's over here, S's, and F's. Thank you guys for your time. Have a great day.